The last piece of the puzzle for our character is calculating the velocity using our calculate velocity variable. So this one is going to calculate a new velocity and return it from the function. We are not going to modify any variable directly from there. This is a general good practice when programming to avoid mutations in your code, to group them together in one place. This is what we are doing. In physics process, we update the velocity variable. And we are not going to touch also our exported variables as much as we can because these act like constants. We're going to modify them in different states, but the idea is we try to modify the properties of our nodes the least possible, because mutation is the main source of bugs in development. So going back down to our function, I'm saying all that because we are not using the static keyword, and we're not using it because it prevents us from accessing these values that we created up there directly, requiring more arguments for the functions and making them a bit harder to change or less convenient. But so, as I was saying, we're going to take the current velocity of our character. It's going to be a vector 3. We're going to take the move direction that we calculate in our physics process function. And finally, we're going to take the delta value. We don't have to pass it to the function. We can get it from the function, but we're going to pass it through here. And straight away, you'll get an error in physics process because we don't have the arguments sent to the calculate velocity call. So let's add them. We're going to pass the current velocity. So it's the velocity variable, followed by move direction. And finally, we'll pass the delta time. And from there, we can calculate our new velocity. So we're going to create a velocity new variable that's going to start the same value of velocity current, and we're going to return it from the function, that new velocity. Again, it's a general practice in functions so that you don't directly modify arguments so that you can compare them when debugging, those kinds of things. That helps avoid bugs or fix them faster than just modifying the variable directly. Now, the new velocity is going to be equal to move direction times delta times move speed. So we're going to have some base calculation that moves the character, and then we're going to limit the speed. So if velocity new dot length, if it's too long, if the character is going too fast, so if it's greater than max speed, we're going to limit the velocity. Velocity new is equal to velocity new dot normalized times max speed. As our maximum speed is a single floating point value right now, this approach will have some limitation in a full game. That is that we're not limiting the fall speed separately from the ground movement speed. So this is the limit on every axis, right? So you'll want maybe moving forward to split the ground or XZ speed, the ground plane speed, from the fall speed. Finally, we want to apply the gravity to the character. So velocity new is going to be equal to the current velocity's y vector, velocity current dot y plus gravity times delta. So this is adding gravity downwards, so making the character fall. Now note that velocity new is going to start at the value of velocity current, and then we completely modify the vector, and the move direction's y component being always 0, we need that extra line that's going to calculate the velocity's fall speed or upward speed from the current velocity's y-axis, because this one here, this velocity new vector, has a fall speed of 0. Whatever happens because of the move direction that has a y component of 0, this vector is never going to make the character fall. That's why we override it there again. But with that, you have all the code you need to make the character move. Now, note how I made a mistake there. I'm returning velocity current instead of the new velocity. So you want to replace the return there with velocity new. But with that, we have the function to calculate velocity in place. We will test it in the next video. But note, if we go back to the game scene, that we don't have a ground to move on. So we need that. And that is what we're going to add in the next tutorial. See you there.